Hello everyone, it's me Praveen. Today I am going to discuss a new topic that is called as kinetic energy of a body in case of pure rolling. In the diagram, you can see that there is a plane surface on which there is a some spherical body which is actually rotating with some angular velocity omega, and its center of mass is moving some with some velocity vc. So here you can see there is a point of contact between the spherical body and the surface is P, and this is case of pure rolling, right? So in case of pure rolling, if you remember the concepts, so in case of pure rolling, the concept is valid that Vc is equals to R omega, because in case of pure rolling, this contact point itself acts as a ICR. ICR means this is actually instantaneous center of rotation. This is instantaneous center of rotation, right? So here we are supposed to find out the total energy of the rolling body. So we know that kinetic energy, here the kinetic energy holds two types of energies. First one is translational and next one is the rotational. The first one is translational, the next one is rotational actually. In case of the translational kinetic energy, we will calculate half mvc square, right? Which is going to be translated here only center of mass. So that's why in case of translational, we will use half mvc square. In case of the rotational, we will use half ic into omega square, right? So this is basically formula to find out the total kinetic energy of the body. Now, as you know that in case of pure rotation, in case of pure rotation, Vc is equals to R omega. That's why omega can be given like Vc by R. And there is one more thing that Ic can be written like mk square. Then what is the k? K is actually radius of gyration. This is the radius of gyration, right? So this is the radius of gyration. Now try to rewrite the above equation in another format. So when you will write this equation in another format, you will get k is equal to half m vc square plus half ic is actually mk square into, rather than omega square, try to prefer to write vc square by r. Right? So from here, what you can take common? Look at the both. From here, what you can take common? So here there is a k. K is equals to, you can take half mvc square common to put out half mvc square. Now here you will get 1 plus k square, and there should be r square other than r. So k square plus r square. So here the total kinetic is given by. So here kt, we will write key total actually. Must have to write key total, right? Key total is actually half 1 plus k square by r square and half mvc square. Now here this is the formula to calculate the k total, right? So this k square by r square is something a constant. This is a constant. So this is the constant actually that is given by the c. So c is k square by r square. As you can see that this depends on the shape of the body. It depends on the type and shape of the body, right? Type and shape of body. Okay, so this formula can be written like in one more way, that total k total is equal to 1 plus c into half m vc square, right? So this is the formula. This is the formula which can be used to find out the total kinetic energy. Okay, so just look at the board once again. Where we have started, this was a this was some spherical body. For this, which was actually rotating on a plane surface, and for this body we have calculated the total kinetic energy. The final formula of the energy is K total is equals to 1 plus C into half mv square. Try to note down this formula. On basis of this formula, we will try to solve some repeated questions of emails. Okay, class. Then wait for the question on this formula.